So we're live now. Okay. Hello, everybody. Welcome to Keras Community Day, Seattle. My name is Margaret Maynard-Reid. I am the lead organizer of GDE Seattle, and I'm based in Seattle. And tonight, or morning for India, we have this amazing lineup of speakers from India, and they are my fellow ML GDEs and top contributors to Keras, and also very active members of the Keras community. So, Aritra, could you advance to the next slide, please? Okay, great. So tonight we're going to have 5 talks. And the first talk is Keras 3's All You Need. So with that, let's please welcome Aakash and Aritra for the very first talk.
Hello. So thanks, Margaret, for the lovely intro. I am Aritra, and joined with me is my co-speaker for the day, Aakash. And what we'll do is we'll talk about Keras 3, which was previously known as Keras Core. And now if you do a pip install Keras, you're going to get this flavor of Keras. What to expect in this talk? So I will be going into the theory part of Keras 3, and Aakash will go into a demo of Keras 3 with JAX. And people who have worked with Keras, you already know that Keras works with a backend called TensorFlow. But now with Keras 3, you can work with any backends that you want. So starting with deep learning, as to this slide, what I tried to intuit is that deep learning is nothing but tensor manipulation, and everything that forms on top of it is a layer of abstraction. So any numerical library, say TensorFlow, PyTorch, JAX, even NumPy, can do all these tensor manipulations. But what about updates? So think about your deep learning paradigm to be a large container with weights and biases. And you do a forward propagation and you also do a backward propagation on which these weights and biases are being tuned iteratively according to the loss. So this del loss with del weights is the gradient of the loss with respect to weights. And once you have that gradient, you back propagate the gradient throughout your network, and the network kind of changes and tunes to give me better losses, right? And to do these updates, there are not a lot of numerical libraries that does these updates, and this updates is possible because of a concept called automatic differentiation. And TensorFlow has this tf.gradient tape, Torch has this torch.gradient, and JAX has this jax.grad individually in its own repositories, which can update these weights and biases with respect to the gradients that get flowed in. Now, what if we have a common interface to leverage them all? So deep learning is tensor manipulations. Tensor manipulations, we go into backpropagation to update the weights and biases. And then we go into each and every tensor manipulation numerical libraries and automatic differentiation. So the ideas are quite common. Why don't we have a common interface to leverage them all? And that is where Keras 3 comes in. So people who have been using TensorFlow.keras or who have been using the original Keras, which had multi-backend capabilities, Keras now again has multi-backend capabilities, wherein it can harness TensorFlow, Torch, NumPy, or JAX seamlessly, and it is a drop-in replacement for tf.keras. So another point that I wanted to mention but not talk in details is KerasNLP and CV. So KerasCV is a computer vision first library, which is being talked about in this live stream by Suvaditya, and also KerasNLP is something which will be covered in a later talk by Anshuman. So not going into depth inside of the two repositories. So, as the creator of Keras himself talked in one of his tweets, is that Keras had a code base was like 135K lines, and Keras Core or Keras 3 has a code base of 43K lines, and that huge jump from 135K lines of code to 43 was all because of TF1 technical debt, and that is kind of removed in Keras 3. So you don't have to have a particular backend to work on Keras. Keras can be thought of as a UI to all the backends that you can ever imagine. So one thing that is really interesting to every deep learning engineer out there with the Keras 3 announcement is that you can write one basic Python script in which you have your models, you have your compile statements, you have your optimizers, losses, and whatnot. And you can use the famous model.fit, or infamous, I might say, model.fit, in which you can train your entire model, and it works with any backend of your choice. So if you are a TensorFlow first kind of a person, you can use that. If you are from research, and we have found that most of the people in research already work with PyTorch, so if you are into research, you can work with PyTorch as well. If you are familiar with the speed of JAX, I'm sure you might have already moved into JAX, and Keras 3 has this immense support for JAX as well. So feel free to use any backend. This script is just going to work. And it's also a drop-in replacement for TensorFlow, so that any issues or people who already have code bases with TensorFlow do not have to face any issues. And it's just a drop-in replacement for that. And KerasCV and KerasNLP, this is already going to get covered by Suvaditya and Anshuman, so not talking a lot about this. And why use Keras Core or Keras 3? So it's one API. That is something which we have iteratively talked about. It's seamless to switch from one framework to another, and in the process, as of now, there is a dynamic backend class inside of the repository which can also help you to seamlessly switch from one framework to another inside of your Python script. That is, you don't have to just have one backend. You can have multiple backends in your environment, and the class can differentiate between them. Keras core.ops or keras.ops is a package to develop backend agnostic operations as well. So if you are familiar with tf.nn.something or pytorch.nn.functional.something or jax.lags.something, you just have to have those ideas and get propagated into keras.ops, and everything is going to work because it knows which backend to place the function to. So another little interesting thing that I and Aakash thought was interesting was that it mimics NumPy API. So everybody coming into the deep learning world already knows about NumPy somewhere or the other. So if you have knowledge about NumPy, you can seamlessly switch into Keras because keras.ops or the operations package mimics the NumPy API. But NumPy does not have its own neural network functionalities, and that is where Keras kind of delegates those neural network operations to the backend which you are going to use, and it's highly customizable. It's Keras; it has to be. So talking about one API, this is basically it. You have import OS. You just have to set your Keras backend environment variable to the to TensorFlow, JAX, or Torch to the backend of your choice, and everything is going to work off the bat. So that's kind of interesting. Again, seamless switching. So if you import Keras, you are going to you can switch from one backend to another inside of your Python script as well. And this is where the NN functions come into play. So np.arrange x of numpy, that is a numpy arrange or a numpy array of 5 elements. So does keras.ops.numpy.arrange has 5 elements. But now if you do a np.softmax, which is a neural network specific thing, does not have an attribute in numpy. But if you do a keras.ops.softmax, it does have a API for that. So just think about NumPy plus a lot of neural network functionalities packed inside of the Keras repository. So that is what essentially you're going to get. So if you are familiar with NumPy API, you can write code on your own with the NumPy API, but just remove the NP with ops, and everything is going to kind of seamlessly work. And if it does not, please feel free to raise a bug, or maybe go into the documentation and see for yourself whether it has already uh, occurred with other people, and if there is already a fix for that. So it's highly customizable because if you want to work with JAX, Torch, TensorFlow, and whatnot, you have your own automatic differentiation engines from these backends. And Keras Core kind of understands which backend you are going to use, and it can delegate those automatic differentiation parts to those backends, and it can be highly customizable one on top of the other. So that's what it does. And talking about advantages of Keras 3, so it supports cross framework data pipelines as well. So if you are a deep learning engineer, the first thing that comes to your mind is, how do I ingest all of this data? And once you understand how you are going to ingest your data with maybe tf.data.dataset, or torch.utils.data.data loader, or numpy arrays, pandas, or pi datasets, you have your data pipeline ready. But now, if I tell you that you don't have to think about all this, you just need your data, you just need any data loader, you need Keras 3, which gives you the models, which gives you the automatic differentiation backend engines, which also gives you the compilation and also the infamous model.fit. And the backend agnostics of Keras 3 kind of lets you have your own data pipeline. So if you want to have a backend of TensorFlow, but also remember you have to have your Torch Python package inside of your environment, and you want to have a data pipeline of data loader, it is going to work. And if you have a tf.data.dataset, but you have a Torch Vision API, it's just going to work. So cross framework data pipelines are something that we are going to have. We also like pre-trained models, who is going to train everything from scratch in 2023. And KerasNLP and KerasCV gives you all these pre-trained models off the bat with Keras 3 compatibilities. And I am sure Suvaditya and Anshuman are going to cover more about that. And something which is thrown around a lot in Keras community is progressive disclosure of complexity. So all the goodies of Keras, that is, start simple, customize as per your needs, go from sequential, functional to maybe train steps, is already packaged into Keras 3. We didn't remove that. It's just that we have other goodies inside of Keras 3, wherein you can go for backend agnostic uh, models, backend agnostic compilation steps, data pipelines, and whatnot. And it also introduces the new stateless API for pure functional programming. And turns out that Torch and TensorFlow have a thing in common, which is object oriented programming, while JAX is not. And we are going to cover that with the demo that we have in store. So JAX, being a pure functional programming paradigm, comes from a pure functional programming paradigm. It has to have stateless APIs, and Keras 3 has stateless APIs inside of it to help JAX work on top of it, right? And distributed training is easy, quantization is easy, and something which Rajesh is going to cover in a later talk is about quantized models. So that is easy as well. And I will not blabber enough. I'll straight away go to the demo, and over to you, Aakash.
Thank you, Aritra, for the nice demo. And like as Aritra said, like the goal of Keras is to unify the ecosystem. So you might have seen like whenever there is a major framework that comes out in the ecosystem, new APIs come out, and like there is a lot of fragmentation. And with Keras 3, our goal is to unify the ecosystem so that you don't have to worry about the fragmented APIs that are lying around the system, that are floating in the system, and you just need to learn about one API and be seamless, be be seamless with it, and like you just need to focus on the development part. So in this particular talk, like I would demo a very simple code example, like we are doing image segmentation, and I will be using JAX backend for this. So, and we can do distributed training as well, but for the time being I will just show you the very simple case where like you can use the same fit API but with the JAX backend. Next slide, please. Yeah. So we will take the Oxford pet dataset, which has like 5,000 dogs and like around 3,000 cats. And there are tri-maps, which are like three classes of segmentation. Like one is the border pixels, one are and the other pixels belong to the pet, and the third category is like where the pixels are belonging to the background. So we will use JAX backend. We will build the data pipeline. We will build a model and use the same fit API, but again with the JAX backend, and it will work seamlessly like it works in tf.keras. Next slide, please. Yeah. So this is these are some examples which you can see on the right hand side. So you have a pet like a cat or dog, and like these are the segmentation masks that we have to like figure out the segmentation mask from a model. So we will build a model for a segmentation task, and we will do inference as well. Okay, so just like Aritra pointed out in the talk earlier, like we can seamlessly switch between backends, and you just have to set the environment variable to the particular backend that you want to use. In this case, we will be using JAX, so we will like set the backend to JAX. And for data pipeline, although like you can use any data loader, like if you had to use tf dataset, then you can use tf dataset. If you want to use torch data loaders, you can use that as well. So for example, I could have like used tf dataset which comes with this particular dataset, so I could have like loaded this dataset using that as well. But for the sake of demonstration, I will be using py dataset, which is like a utility for python based objects, right? So you can define your data generators using py dataset. It is if you have used Keras sequences in the past, it is an extension of that, but much better than sequences. So there are some improvements in this class, but it is very similar to sequence class that existed in the old Keras. So there are some functions in the dataset which we are going to implement. And we will be using Pillow for image processing. Why Pillow? Because it's a very common library that is being used for image processing and image manipulation, but you can use OpenCV or any other library as well. So the first method that we are going to define in our data pipeline is the init function, like where we define simple things like what is the batch size, what is the image size that we want from our data pipeline, what are the image paths, and what are the target segmentation map paths. And then we will have certain utilities like do we want to shuffle our data set on every epoch or not. So this is our first method. The second method would be like the length method, where we will figure out like how many steps or iterations are there in a particular epoch. So for example, depending upon the batch size, how many times like you do an iteration in a particular epoch over the data set. Yeah. And on every epoch, if you want to shuffle your data set, yeah, like you can do that as well. And we will shuffle the dataset if it is set, which is like very common for sorry, for training dataset, and for validation dataset we will keep it as it is. Next slide, please. And then this is the get item method. Like every time you call your data loader, like you will get a batch of images and the corresponding segmentation mask. This is a very common utility, which I think like everyone is familiar with. We are just loading the images, the mask, and like resizing them with some interpolation, and like then like loading these images and mask into a numpy array and returning those numpy arrays from this data pipeline. Next slide, please. Yeah. Now that we have defined our data pipeline, we can define our model, and we have like again, because this is a we want Keras to be the unified interface. So whatever things that you are using in tf.keras, whatever model building utilities that you are using in tf.keras, you can use those in Keras 3. So here I am using the same API for building the model. Like for example, you can see like I have the input layer, the con2d layer, and the functional model API for defining my model. So you can use the same APIs that you were using in tf.keras in Keras 3 and train the models in a similar way, but with multi-backend. Next slide, please. So we will define a unit like a model for this particular example, and you will see that like the APIs that we have in Keras 3 are exactly the same which we had in tf.keras, whether it's optimizer, callbacks, losses, but there are a lot of improvement in these APIs because we don't have the technical debt now. And as Aritra pointed out, this is a drop-in replacement for tf.keras. So if you have something that is implemented in tf.keras, you can just port it in Keras 3 and it will work as it is. So unless you have something very specific to TensorFlow, it's very easy to port the model to Keras 3. But if you have something very specific to TensorFlow, then you can re-implement it as well with the operations package, so that like it is backend agnostic. So these are the building blocks for our model. So for example, this is a downsampling block where we have used like convolution, batch normalization, and activation functions. So every time like you pass the image through this convolution block, like it will be downsampled. Similarly, we will have another block which is upsampling block. So once we have like extracted the features and now we are building the segmentation map, we will be upsampling those feature maps again back to the original image size. So it is again like transposed convolution, batch normalization, and activation. And you can see like building a unit model is as easy and as pretty as on this slide. So you can fit the entire model in a single slide. So it's very clean in terms of model building. So another advantage of using Keras is like when you are building things, it's very easy, and the code become very clean. So people who are using your code will find it easy to read, easy to implement, and easy to use, and easy to extend as well. So this is our like unit model which we are using for segmentation, for doing segmentation, and we will train this model with the fit API. But here again we are using the JAX backend. Next slide please. Yeah, so just as I pointed out, like all the APIs that were there in tf.keras, they are ported to Keras 3 and have major improvements. These are like drop-in replacements. So if you are used to those APIs, you can exactly do the same thing in Keras 3 and like harness the power of other backends. For example, if you want the flexibility of PyTorch, you can get PyTorch flexibility using in Keras 3. And if you want to like if you really love speed, like you can use JAX backend because it is the fastest one. So here like I'm defining the optimizer, the callbacks, and then I can compile the model like we are used to do in tf.keras, and then we can train the model. So here I'm like training the model for 20 epochs with the fit API on a single GPU. Next slide please. Yeah, and once you have trained the model, you can see that we can validate our predictions on the validation set. So we take a sample validation batch and like do the predictions on top of it, and you can see the results on the right hand side after 20 epochs, which is a good result in my opinion. So you see like building things in Keras 3 with multi backend is as easy as it was in tf.keras, and because it doesn't come with the technical debt and has a lot of improvements on the APIs that were implemented in tf.keras, I think this is the perfect example of having an API that can give you everything from developing in the most intuitive framework to deploying in the fastest framework thing. So once you have that mindset, so you can like develop very complex things very easily and at a very fast speed, and then you can deploy as well in the framework of your choice. So that's why like we think like going forward, Keras 3 will be the major API that will be used by a lot of people in the future for all the three major frameworks, which is like TensorFlow, PyTorch, and JAX. And we are not like limiting ourselves to these three frameworks only. So if you think like there is another backend that is very popular in the community, you can actually go and create a PR for that backend as well. And if it is popular, we can add it to the repo and you can use that as well. So yeah, so that's the demo that I wanted to share with you guys today. So for references, like you can go to these links and read about more like how are things being developed in Keras core and with multi-backend stuff. And yeah, we are very grateful to Francois for guiding us throughout the process of building Keras 3, and we are very grateful for the developers program and Google developers expert community for their feedback, for their help, and all the feedback that we have got during building this, during the development of Keras 3. Yeah, thank you. And if you have any questions, I would be ready to take questions. If anyone have any questions.
Yes, thank you very much, Aakash and Aritra, for the great presentation. And I think a lot of the things you're showing us is actually new, right? Because the announcement just came recently.
Yeah.
Yeah. Okay. And there is one question. I'm sharing it on the screen. Can you see?
Yes. That's a good question. Like, people are always eager to know, like, what's the performance difference when it comes to different frameworks. So one of our friends, Sayak, has done a benchmark where, like, you can compare this thing, and there is also another benchmark that was done by Keras team, where we have the same setup for all three frameworks, and you got the timings. So I will share those resources in the chat section so that you can take a look into it. But just on the top of my head, I can tell you, like, uh, TensorFlow is much faster than Torch, and JAX is much faster than TensorFlow. So for all the three frameworks, JAX is crazy fast. Then comes TensorFlow, and then Torch. And by the way, one more thing, like, the good thing about Keras 3 is, like, uh, we support XLA by heart. Like, everything that goes in Keras 3 is compiled, so you can expect a huge performance difference when coming from tf.keras to Keras. So you will get a speed bump even for TensorFlow.
Right. Thank you. Are there any other questions? I don't see any other questions. And also, I hope that people in the webinar can also hear us. I think, John, you're from the webinar, right? And then Bernard, you're watching the live stream. So this is the first time I'm trying to use both webinar and the live stream. I thought the webinar would allow like audio of the audience, but apparently may not be the case, because I'm wondering if I could hear actually someone asking a question. Yeah, thanks for confirming, John, that you can. So the Carrie is asking me if the YouTube link work for later viewing. Yes. I believe this is a live stream as well as recording to the YouTube channel. I see. Aaron, thank you for letting me know. So you said there's only a text box, not a way to share audio. Okay. Then I don't see what's too many difference between the webinar and the live stream, because on the live stream people can also ask questions via the chat. Although I think with the webinar we could save the questions, but I was hoping for audio. Anyways, are there any other questions related to the talk that Aritra and Aakash just gave us? Okay, so if there's no other questions, thank you very much, Aritra and Aakash. It's great to have you here, and we're gonna move on to the next talk, which is KerasCV for the Young and Restless by Suvaditya. So I am gonna add you. Bye, Aritra and Aakash. So welcome, Suvaditya. Yeah, the
Thank
stage
you
is
for having
all
me.
yours. And I am gonna. Could you share your screen, please?
Absolutely.
And I think, yeah, I think Aritra is sharing with the agenda, but it's okay. You can share your screen, and then I will add it to the stage.
Yeah. I hope it's visible now.
Let's see. I only see me and you, and I don't see your screen. Did you click on present in the studio?
I did. In fact, my screen is sharing. I think you need to add it to the stage, I believe. That's probably.
Okay. I am not seeing
Yeah.
your screen. Okay. Let's see. Okay. Whoa,
Yeah.
that's
There you go.
not the right one to add though. Oh, there it is. Great.
Yeah. Right. Okay. So, good evening, everyone. My name is Suvaditya Mukherjee, and today I'm going to be demoing and talking about KerasCV for the young and restless, and give you a very quick run through of how you can go from having a very general idea to complete industry specific workflow just using KerasCV. So, a quick who am I? I'm a GD for ML, TensorFlow Core Keras. I'm also a research intern at a computer vision lab in India. I'm also the co-organizer for GDG MAD in Mumbai, India, and I have previously been an intern and a GSoC organization admin at Ivy, which is a YC startup company. I'm currently also a senior year undergraduate in an university in Mumbai, and I've also been previously a GDSC lead. And in my free time, I love watching Barcelona games, so hit me up. So, the few things that we want to cover today would first off look towards what is computer vision and what are the different tasks and problems that we solve within it. Following that, we'll look at why KerasCV is important, who is KerasCV, and who is this magical being that will solve all our problems related to this one full paradigm of machine learning. And then we'll look into how KerasCV can solve some of the more detailed problems within computer vision. Lastly, we're going to take a demo, or we're going to be looking at a demo of KerasCV, and we're going to top it off with some resources and some references that you can use to further your journey into KerasCV. Computer vision is just CNNs and deep learning. Well, folks have been very generally uh, not very knowing of the fact that computer vision is a very large field. It has several different things before even neural networks came around, and the fact that computer vision encompasses several different tasks. Well, before that, there were solutions. Before neural networks, these problems were being solved. Algorithmic methods do exist to perform most of the tasks that we see in computer vision today. Most of them. Look, for example, what you see right over here on the slide is an image that has been denoised, that has its blurring effects removed. There are many algorithmic or numerical methods that exist for doing things like these, but then they failed when we asked them to do stuff like this, when we asked them to do more complex tasks. Because when you try to move from a playful idea to an actual research problem or an industry problem, you up the ante a bit. And that is when neural networks came to our rescue. Computer vision and deep learning is the best of both worlds, right? Or is it? It's the best of all worlds. When you have traditional algorithms that fail, that's where neural networks come in and save the day. They solve the kind of problems that normal ones can't. So, who is KerasCV? For the folks who are beginners, for the young, it is a library of vision oriented Keras components that start with how you can develop very simple workflows. It supports a large number of features that can include XLA compilation, support for TPU training, support for mixed precision training, quantization, and so much more. And now, with its new backend for Keras Core or Keras 3, you can also start running within the JAX and PyTorch backends, aside from the TensorFlow backend that already did exist. KerasCV can form the base for making absolutely anything that you can think about. It can be helped for industry grade deployments of computer vision. You can use it for onboard GPUs for edge ML, or you can even use it for mobile phones or edge devices. You can use KerasCV to develop all of these at the same time. And lastly, you get a ton of pre-trained components out of the box. For example, as we're going to see in the demo today, we're going to be looking at stable diffusion and how you can get started with it directly using Keras CV, and some very awesome documentation to go with it. For the folks who have already started going around Keras and they're pretty restless on what can we do with this. Well, there is support for a ton of new models that have been coming out: Stable Diffusion, YOLO, CSP Darknet, Efficient Net, Segment Anything as well, and all of these in JAX, TensorFlow, and Torch. Other vision tasks are now first class citizens of the library. Segmentation models are being added in full swing, and object detection has been a major focus of the library, which is now going to translate into better component availability within Keras CV. We also have a very modular API to mix and match the components that exist. And again, as I mentioned, some very awesome documentation to just directly get started with whatever you want to do. So while I just talked more about what you can do with Keras CV, now let's jump into what it actually looks like, right? Well, if you want to if you want to use KerasCV for, let's say, image augmentation, you have the latest augmentation techniques like augmix, cutmix, Fourier mix, and more. Well, if you don't know what they mean, either you can Google, of course, or you can use Bard, or if you don't want to take the hassle, you can very much just use a random augment. And not only do these augmentation techniques work directly on the image data, it also has support for bounding boxes. So you can rest assured that if you're working on a problem that is not image classification and is a bit more involved and has bounding boxes, well, you don't need to do it separately. KerasCV will handle it for you. Now, let's say you want to do some object detection, right? Uh, as you can see, there's a lot of problems going on in there. So, in such a case, what you can do is use KerasCV. You have full support for YOLO V8 and RetinaNet. And newer models, again, are being added as we speak. 2D and 3D modalities, both of them are supported, and more around 3D paradigm is coming as we speak. And as I mentioned before, newer models are in the pipeline. So the newest models that do come around from the research paradigm, and need to be translated into the industry paradigm, you can rest assured that you'll see it in KerasCV in a few days. KerasCV for image segmentation. Well, rapid development is going on towards segmentation models. As I mentioned, Segment Anything, which is a very famous foundational segmentation model from Meta AI, has now been included within KerasCV. It is in the process. So you can expect to start using it very quickly. Powerful visualization APIs are already present. Well, shout out to Aritra. He is one of the seminal folks who worked on it. And lastly, if we're looking at the more common thing of today, the where we look towards generative AI, well, let KerasCV help your imagination run wild. We have support for pre-trained stable diffusion and a lot of elaborate documentation on how to play with it. And while only the base stable diffusion models are available, we do also have extensive documentation on how you can move towards textual inversion or dream booth or more applied versions of stable diffusion very quickly with Hugging Face as well as just Keras alone. Well, let's take Keras for a spin, right? Well, it's time to get your hands dirty, or at least watch me do it. Um, what I'm going to show you is a very quick demo of the notebooks that I have with me. Um, I hope this is visible. Yeah. So I took the liberty of starting the VM a bit beforehand. So let me just give you a very quick example of what we're going to be doing here. So in this demo notebook, which I will be very happy to share very soon, we are going to be looking at how you can use stable diffusion with different settings within KerasCV. KerasCV allows you to optimize stable diffusion models to a certain extent using different kinds of methods. In the interest of time, what I'm going to do is show the two extremes where you do not have any kind of optimization versus you have all the optimizations enabled. So first off, we're going to be running our imports, followed by some cleanup and some weights and biases logging. Weights and biases is something that we're going to be using for just to make sure that we can get our statistics in one place for experiment tracking. Uh, right. So first off, we have the no XLA and no mixed precision. So what are XLA and mixed precision? XLA allows you to quite literally accelerate your machine learning workloads by compiling your models in a just-in-time format. You can now use XLA within KerasCV, and all of the supporting libraries because of the recent shift to Keras 3 with XLA at its heart, as Aakash said. We're now looking at seeing how we can move forward towards utilizing it much more deeply. So let me see if anyone wants to give a new prompt. I'd be very happy to accept that. I'll wait for a minute or so to see if anyone wants to, jump in with a prompt, which is currently Wolverine trying to pick a lock with his claws. So if you have something of that sort, please feel free to, jump right in. Right. Let me see if I can run this as well. So running this cell, what we're going to do is generate an image from stable diffusion of size 5 and 2 cross 5 and 2 for the image height and the width. And this is the prompt that we've sent in. This will generate 3 images from stable diffusion with the given prompt of Wolverine trying to pick a lock with his claws. For the sanity of using a free collab to your GPU notebook, we are going to delete the models and clear out all the memory that we can in order to make sure that we can run different models in the same session. Let's see. While this goes on, I'd be very happy to take any questions that come around because this will take a short while.
I don't see any questions.
Right.
So, because normally if people have questions, they will enter it into the chat box.
Yeah. Yeah.
You're very brave to do a live demo in your talk
Oh,
and try to wait for the result too.
oh yeah, oh yeah. So this demo is something that is very well tested. I tested it around a lot before, making sure that I bring it to the session today. But I'd be very happy to show some benchmarks that I have had before while I was running it for a separate session. So, in the interest of time, I'll just make sure that I can very quickly demo the other side of things over here very quickly. Let me
There's
see.
one question.
Yeah.
I'm showing it on the screen.
Yeah. What
So
is XLA
people,
and mixed precision? Oh, yes.
yeah.
Yeah. So I was actually hoping to show that once the no part of it was cleared, but very happy to go about it right now. So XLA is a technique for compiling your network, compiling your code for machine learning in a way that is far more optimized than what you'd have with simple uh, Python, basic Python code that you're writing, right? So XLA will basically accelerate your machine learning workload. And if I were to very easily generalize this, it would be somewhere around the concept of using a compiler versus using an interpreter, where you're trying to speed up things by using a compiler and making sure that everything is very much fixed. So when you know that your pipeline is pretty much the same every time you're going to run it, you can in theory use XLA and get a major performance boost. As for mixed precision, well, mixed precision is a technique with which you can reduce the size of your model and by extension reduce the computation time required for it. This allows you to make your model far smaller than it already is and directly start using it in far more resource constrained environments like the one that we in currently, where with a free tier Google Colab notebook with GPUs, you'd have maybe let's say 12 gigabytes of RAM and you wanna run larger models. So mixed precision will basically cut down the size of your variables. So after all, every model is just weights and biases, right? So the weights and biases that exist in the form of variables, normally of the size of 32 bits or 64 bits with float data types. So with mixed precision, these 32 or 64 bit float variables get converted into far smaller precision variables to the size to the tune of 16, or with other libraries you can even go down to integer 4-bit, 8-bit, and so on. So you can reduce the size of these models by a large scale and you can gain exponential boosts. Yes, this has performance impacts, but those degradations are far too negligible when it comes to actually seeing how it works in general. So, yeah, okay, it seems that the first run is complete. Let's see. Mm, yeah, let me see if I can just use a separate benchmark that I had created before. So, if you look carefully at this graph right here, uh, this is a chart that denotes the generation time that is required to generate three images from the notebook that we just saw. So over here, you can see that the images have been generated and we can see some of those images right away. Well, while this happens, let me see if I can run the last one. So with if you want to see how you can start with float 16, well, this is quite literally it. This is all you need to do to get started with mixed precision, where you just need to set the global policy to mix float 16. Where it can, it will use float 16 variables, but where it does recognize that float 32 variables are required, it will keep them just as it is. Lastly, for compiling with XLA, all you need to do is pass this flag right here, JIT compile equal to true. That's it. And you can very quickly go from having a slow model to a very fast model. Let's see, it'll run on its own. But while it happens, I'm very happy to show that the generation times, if you compare, well, with no XLA and no mixed precision, you can see that the generation time goes up to 242 seconds, which is what we saw, right? But when you just enable mixed precision, that goes down to 61 seconds. That's the kind of performance boost you can see, almost 4 times lesser uh, generation time. On the other hand, if you just compile with XLA, but you do not have any kind of mixed precision involved, you're going to see a performance boost of up to 3 times with 93 seconds as your generation time. Keep in mind that these are all generated on a free tier Colab notebook, and with better GPUs, you can reduce this generation time far more. But when it comes to actually enabling both of them together, where you have XLA and mixed precision, you can see that the generation time has gone directly from 242 seconds to just 30 seconds. So that's the kind of difference that XLA and mixed precision together can make. While you can see that in this demo right here, the only two things of concern that bring us to using JIT and XLA are mixed float 16 and equal to true. Right. So with that, lastly, I'm just gonna take up the trip, right? So for the folks who just want to get started, well, Keras.io has a ton of examples around computer vision. You can also check out PyMed Search and Towards Data Science for some very general computer vision tasks. For the ones who want to start building, well, you have the first principles of computer vision, the documentation of KerasCV, and Hugging Face computer vision tasks very easily available. So that's it. We've covered what we want to do with KerasCV, and I hope this has been a very brief introduction to KerasCV and how you can go about working towards building your computer vision workflows with it. Thank you.
Great. Thank you so much, Suvaditya, for your talk. And then thank you very much. And then we are going to move on to our very next talk by Usha, ML GDE. Bye, Suvaditya. Thank you. Hello, Usha. I think you're on mute. Could you try? Hi, hello.
Yeah, hi.
Welcome, Usha.
Thank you so much for inviting me for the session. It's my pleasure to be here.
Would you like to share your screen?
Yeah.
I don't see your screen being shared.
Actually, mine is a notebook, so it doesn't allow notebook. Does it allow notebook?
It doesn't allow notebook to be shared?
No, it is. It is allowed.
If you share your slides with me, do you want me to advance your slides?
Yeah. Is it visible now? I've shared my screen actually.
Oh, you did? Okay. There we go.
Yeah.
Great.
Yeah. I'll start now. So yeah. In today's talk, I'll be discussing about how to compete in Kaggle using Keras Code and Keras NLP. So for this talk, I'll be using Kaggle, one of the current competitions in Kaggle, which is Kaggle LLM Science Exam. So, a brief introduction about this competition is a question answering problem, and all the questions of this competitions have been generated by LLMs. So, most of them were generated by GPT 3.5 snippets on text which is pulled up randomly from Wikipedia. So the whole problem is about using LLMs to actually answer these questions and the options which is being given for each question to answer this using LLMs. So the maximum LLM size which you can use in Kaggle is 10 billion, but the question answers has been generated by GPT 3.5, which is 175 billion parameters. So the whole perspective is they're trying to figure out is like, can smaller LLM models is the questions which has been generated by the bigger models like ChatGPT 3.5. So that's the whole context behind this problem statement. So coming to the data sets which is being given to us, we have training CSV file and test CSV file and sample submission CSV file. So in training CSV file, we have about 200 questions and we have an answer column as well. And in test CSV file, we do not have an answer column. And sample submission is about how you make submissions to the Kaggle. So this is how the data frame looks like. The training data frame looks like you have an ID, you have a prompt. Prompt is nothing but the questions. For each questions, there will be multiple options, A, B, C, D, and E. And you'll also have a column called answer, which will tell you like which is the correct answer of all of it. So this is the training data set which we have. The test data set will not have the answers. And so you'll have to use LLMs to solve this problem, question answering problem. So I've written a notebook which uses GPT-2 from Keras NLP. This is my notebook. You can go to Kaggle and filter this notebook, from the competition section as well. But today I'm going to use another Kaggle Grandmaster's notebook, Aswaf. My notebook is actually, inspired from Aswaf's notebook. So I'm going to use Aswaf's original notebook for the demo. So why Keras NLP? I think there's going to be a session which is going to come, the last session for today's webinar. There'll be a deeper session on Keras NLP. But a lot of notebooks from this particular competition has been using Hugging Face and other libraries, but Keras NLP gives you much more flexibility when you want to pass custom, when you want to do custom pre-processing and things like that. So there's a lot of flexibility which comes with Keras NLP. So let's get started with the code walkthrough. So I'll be installing the libraries which I require, which is Keras Core and Keras NLP. And these are my libraries, the other libraries like NumPy, Pandas, Matplotlib for visualization. And for Keras Core, I'm using PyTorch as my backend. You can use navigate between TensorFlow and JAX with just minimal change. You can reuse a notebook with JAX as a backend or TensorFlow as a backend with just small changes here and there. So the next thing is about the configuration. So before I start my pipeline, I have created a class where, I have listed out all the configurations, like what kind of models I'm going to use. For this example, I'm going to use Deberta V3. And what is the accelerator? You can run this notebook on TPUs, or you can also use GPUs for running this notebook, whatever accelerator you feel like. And there's the other basic parameters like what kind of schedulers, whether there's an augmentation, number of epochs. So all these basic configurations, I'm going to put it in a single class. And for reproducibility, I'm going to use Keras utils random seed for reproducibility. And so there is a small code snippet for the initializing the accelerator. So in this notebook, if you have enabled TPUs, it will automatically, this piece of code will automatically detect it and it will initialize the TPU cluster. And then if you have enabled GPU, then it will automatically detect the GPU and initialize it. And if you've enabled CPU, and this piece of block of code will get called. So here this notebook runs using GPUs. So I'm just setting my base path as a directory where the data set is present. So now let's analyze the distribution of answers A, B, C, D, E options in the training data set. So if you take the train CSV file, how the answers are distributed. So if you take the options A, B, C, D, E, so this is the distribution of answers. So this is not very imbalanced, but there is a lot more answers with B options and C options compared to E. So for this competitions, in addition to the competition data set which is given by Kaggle, there are also like external competition data sets which is released by a lot of competitors. And so this particular notebook uses 3 of these external data sets. It combines all these 3 external data sets into a single data set. So there is one data set which is competition data set, and there's another data set which is the external data set. And if you see the distribution of answers for the external data sets, again, you have C and E, the more C and E options compared to A. So this is the answer distribution in the external data sets, which is created by several Kagglers. So now I'm going to concatenate both this external data sets and the data set, the Kaggle data set, which is available for training. So before we get started with training, I'm just going to revamp the data set a bit. So if you take the current data set, you have an options like this. So you have a question, and then you have answers like A, B, C, D, and E. So if you have to send this particular single row for training, it's going to be a very, very long sentence. And so, if you want to shorten it a bit, because we're going to use smaller LLMs, if you want to shorten this whole pattern a bit, there is one of the shortcut or one of the recommendations on how to shorten that long string. So instead of having a single question and all the options happened, you can actually break it down like question and option A, then question, option B, question. So you're just converting this single question and multiple options into question, answer, question, B, and question, and then option C, question, and option D. So you're just reformatting the entire thing. You're creating a new column called options, and you are creating a new question and option pair. So now it will look like this. You have a prompt and you have all the options. You have the answer ID label, and you also have the options column where you are taking an option and pairing it up with, taking a prompt and pairing it up with each options available. So this way you are shortening the input size which you're giving as an input. So that is what this utility function does. And yeah. So then for pre-processing, we are using Deberta preprocessor. And the way you use it is Deberta V3 preprocessor. You're calling from preset method. This allows you, this gives the users a little bit of flexibility to pass their own inputs. For example, you can define your own, what is the max sequence length you want to pass it to the model. And here, like, whatever. So there is some kind of a flexibility on customizing what kind of max length you want to set and things like that. So what this Deberta V3 preprocessor does is it does pre-processing where it gives you an output which is a dictionary which contains token and token IDs and the padding sequence. So let's inspect how the output from this preprocessor looks like. So the output from the preprocessor looks like this. It's a dictionary which contains token IDs and then corresponding padding mask. This is how the output from the pre-processing. So any NLP pipeline you take, the first thing which you do is pre-processing. And so that to get that done, we have a preprocessor from the Keras NLP libraries for each of these pre-trained models. So for Deberta, we have Deberta V3 preprocessor. So once you convert the preprocessing, then there's also one augmentation techniques which is recommended in this notebook, which is option shuffle. This is just created by the author of the notebook. So it is nothing but, instead of always having options A, C, E, D, B in the same order, you can shuffle the orders so that there is no influence on the ordering of the options. So in order to avoid this influence on how the options are ordered, so you can just shuffle them. So this is a function which does that. This just shuffles the options, like whatever present here, into a different order, so that there's less influence on how the options are ordered. And then you can take this training CSV file data frame and convert into TensorFlow's tf.data.data sets. So you can first slice it into text and its corresponding labels, and then you can use tf.data.data set from Tensor Slices API to convert it into tf.data.data set. Then you can do certain pre-processing, like call the augmentation functions. Then you can do certain other pre-processings as well. So once you've converted into tf.data.dataset, then it's about getting the training and the validation data sets. So this is a utility function which builds the training data sets and the validation data sets. So you can also use weights and biases for tracking your experiments. So recently, weights and biases have come up with new callback functions, which has got much better features compared to the previous callback functions which we had. So Kaggle gives you a user secret client to actually store your API keys. So that this piece of code, lets you log into the WANB. So there are new callback functions like WANB, metrics logger, WANB model checkpoint, and all of this which comes with much better features compared to the previous ones. So yeah, this is the learning rate scheduler. Yeah. Finally, coming to the modeling part. So here I've done my pre-processing using the preprocessor, and then I've done augmentation, and the next step is the modeling. So for modeling, I'm using the corresponding classifier, which is Deberta V3 classifier model. I'm just using the from preset, passing the model name, preprocessor, and the number of classes here. So the way this particular pipeline works is, so I'm going to take this question and the option pairs. I'm going to take each question and option pairs. I'm going to pass it to the model backend, and each of it will give the output embeddings, and this will be passed to the classifier to get the this classifier here is Deberta V3 classifier. So any LLM model, and this in turn will give you logits. These logits can be passed to the softmax functions to get probabilities. So this is how the pipeline looks like. So I've taken my original data set, I've did a little bit of formatting to get to this format where I take up a question and pair it up with each option, and then I did the pre-processing, augmentation, and all of that. Now I'm going to pass it to the model. The model here is Deberta V3 model. So that is what this piece of code does. So here, this is my function where I, write what my input is going to be. The input from the tokenizer is going to be a dictionary which contains token IDs and padding marks. This is something which I'm going to pass it to my classifier. So then I'm going to build my model, and then I'm going to call the compile method, configure my optimizers, what is the loss functions and the metrics, train the model, and then it is done. So, and then you can visualize some of the predictions from the model, how it looks like. like a few of the questions and the answer pairs. So you can just visualize some of the predictions from the model. So this is how basic pipeline from, a pipeline of taking a Kaggle competition. This is an NLP based question answering competition. And this is our pipeline, basic pipeline of solving this competition using Keras Core and Keras NLP. There are like a lot more other interesting ways on how you can tackle this problem. This is a very basic pipeline on it to get started with. There's a lot more about Keras Core and Keras NLP. I think Anshuman will discuss in the final session a deeper introduction to Keras Core. With this, if you have any questions, then you can ask.
Great, thank you, Usha. Are there any questions? I asked a question to the audience. I assume everyone here knows what Kaggle is, right? Any questions for Usha? Has anybody here used Kaggle before? Like, use the data set from Kaggle or participate in the competition before? No? No questions? Okay, I do not see any questions. Okay, John said no, just found out what it is. Well, great. I'm glad you did. And Aaron said use the Kaggle data set. This is it. Use the Kaggle data set for putting together a simple demo, but I never competed. Well, I'm glad Usha gave us this talk today, and we learned a lot. One of the things I should have done at the very beginning of the today's event, I introduced myself, but what I should have done is ask every speaker, go around, introduce themselves. And I think I seem to remember Aritra and Aakash talked about who they are. But Usha, did you happen to talk about who you are? Because I put everybody's biography on the event page, but it's different from hearing it from you. Just tell us who you are.
Sure, I'll just show them my Twitter profile. So please
Okay.
follow me on Twitter. Yeah, so I work as a my full time job is I lead a data science research team for a Web3 startup called Exa Protocol. And outside my full time job, I do a lot of freelancing in ML because my full time job is very less scope for machine learning and data science, which is more on the Web3 side. And I'm also an adjunct faculty at few of the universities in India, and I Kaggle a lot whenever I get free time. And I'm actively involved in community. I lead almost all Google communities for Mysuru, which is a city which is 2.5 hours from Bangalore. So yeah, this is about me, and yeah.
Yeah, great. Thank you so much, Usha. And then you and I met in person in Thailand last year at the ML Community Summit, right? It is
Yeah,
great. I mean, we haven't talked to each other since then, so it's really great to have you here. And
yeah,
thank you for your talk.
yeah, it's been my pleasure. Looking forward to meet you in person once again. Thank you so much. Yeah.
Sounds good. Thank you. Bye, Usha. Okay, so please welcome our next speaker, Rajesh, ML GDE. Yeah, you've got your Keras shirt. I have mine too, but somehow I do not know why this camera today is not showing my shirt. The angle of the camera or something. Hang on just 1 second. Sorry, everyone. I am trying.
It looks like your camera is at the top.
Yeah. I am trying to get a picture of both of us with the t-shirt, I think. Not quite right. while I'm trying to muck around with this, could you try share with us your slides, please? While I'm getting ready.
Yeah, sure.
Okay.
Okay. Slides.
And I think our next talk by Rajesh is on quantization aware training with Keras. So far we have heard a lot of the talks on the Keras core, the Keras supporting multi backend and KerasCV, KerasNLP, and then do the competition with Keras. And now we're going to hear about quantization. So let me add your slide to the screen.
Sure.
And yep. So go ahead, Rajesh, please. And also don't forget to give us a brief intro about who you are. So welcome, Rajesh, on the talk, Quantization Aware Training with Keras.
Thanks, Margaret. Hey, hi everyone. So today I'll be talking about quantization aware training with Keras. So myself, Rajesh, and I'm a GDE in machine learning and working as a senior data scientist in Walmart, based out of Texas. So I mainly work in the computer vision domain, where we are trying to deploy things over edge. So kind of deal with quantization during the training process or post the training process. So we'll be going through the details with Keras today. So we'll start with like understand what quantization is, and later we'll go through like different approaches usually people take when it comes to model quantization. So that is post-training quantization and quantization aware training. So then later we'll go through the code example with Keras with CFAR dataset for classification. So coming to the quantization, right? So it's a process of converting the weights and sometimes even the activations as well of a model from a high precision floating point representation to a lower precision floating point or integer representation. So it could be like, I mean, for example, so we could have our model weights in float 32 and we want them to be at a lower precision. So it could be like float 16 or int 8, and the like different other formats with TPU and other options that is available. So mainly what is happening is the large range of values is like kind of getting squished to a very limited space. So as you can see here, like the floating point 32, the range is like very huge. And so those numbers are like kind of mapped to like, let's say if it's int 8, then the possible values are around like 255 or something like that, like minus 127 to 127 plus 127, right? So basically there's information loss that is happening, and so that has effects on accuracy. So we'll go through those details in the coming slides. So why this is important? So basically when we are working with a constraint environment where resources are limited and we don't want a lot of power consumption to happen. So these techniques are very handy and helps in like kind of doing saving the power and also doing the inference in a very fast fashion. So examples are like mobile devices or edge hardware where the resources are limited. So for example, the models could be like, I mean, we have like face unlock, which happens in like less than a second or maybe close to a second. So where the data is not sent to the cloud and the inference is happening on the device. So those are not like full precision models. So those are definitely a quantized models. So that is just an example of one of the examples of how quantized models can be used on mobiles or any other devices where there is like limited resource, right? Yeah, we'll go through the different approaches now. So to start with post-training quantization. So you will be training a model a full precision model, a float 32 model. And then kind of once the training is complete, you will be applying the quantization techniques to kind of go to a lower precision. So it could be float 16 or int 8, right? So in that process, so the model has not seen those quantization effects during the training process. And after the training, it's like kind of all of a sudden the quantization is applied and there's some information loss happening, and that it's affecting the accuracy of the models. Right. So that is one of the disadvantage, accuracy drop when it comes to the post-training quantization. But the advantages here are like faster inference because we are dealing with lower precision models. And so because of that, the memory consumption is also on the lower side. Right. So now the next question is, okay, our model is fast, or model is like kind of very lightweight. But is it, if it's slightly inaccurate, can we still use it? Right. So the answer is yes and no, depending on what application or in which domain we are running this model. So if its accuracy loss is not accepted, then what do we do? Right. So then comes the quantization aware training, where during the training process as well, so we are applying the quantization effects. So sometimes it's called as like fake quantization, referring to the Google blogs or any of the videos that are available. So they call it as like fake quantization there. So basically your model is trying to learn the quantization effects that is applied after the training process during the training process itself. So it's the quantization aware training. So that is how the name comes. So yeah, so quantization is lossy. So whatever the error is introduced with the quantization, now it's happening during the training process itself. So yeah, so the model learns those. Model knows that there is error that is introduced due to quantization, and it tries to kind of get better over time with the training process, right? So which is how like there is not much impact on accuracy when the quantization is done post the training, right? So we'll be going through the code details, where we'll be going through uh, we'll see like different, I mean, train the models with quantization or without quantization, and then look into the model sizes. So I think that will be clear once we head there. Yeah. So yeah, we'll directly go into the Keras code example. So we'll be using TensorFlow model optimization library there in order to quantize the model during the training process. And then so typically we have the, let's say we have the any model, a CNN based model or just a neural network. So we'll have like bunch of layers over here. And then once the model is defined, and then next step is to like kind of quantize it using the TensorFlow model optimization library. So it's just a single line of code. So whatever quantization, different like there are like different ways to kind of quantize. It could be like uniform or linear. There are like different ways. So all those things are taken care under the hood of this particular single line or this particular library quantize model. And once we have the quantized model, it's similar to like how we kind of compile and fit the model in Keras. So it's as simple as that, just a single line of code to kind of say quantize the model that is already defined, and then kind of do the quantization aware training with the next steps, right? So yeah, here in this example, the whole model is like kind of all the layers are like kind of going through the quantization process, but there are like options with TensorFlow model optimization where you can specify only few layers needs to be quantized and not all the layers. So those kind of options are there, but given the time is limited, so we'll be going only through the easiest route and a simple route to better understand. So let's go to the code. Hope my screen is visible, the collab notebook. Yeah, so we'll be just installing the dependencies. So I think since my notebook is up, so it's already installed. Yeah, then we'll be just importing the libraries, TensorFlow, then the optimization, TensorFlow model optimization, NumPy, Matplotlib for kind of visualizing the data set. So here we'll be going through a classification example, a very famous data set, CFA10, where there are like 10 classes for the classification. So just loading the data, getting the train and test set, then visualizing the data that we have. We have like 10 classes. So randomly just taking few of the examples for different classes here, and later defining the model. So we are just, I have just defined a very simple model over here. The aim is to like kind of show the capabilities of quantization aware training with Keras and not focusing on accuracy or any other aspects of the model architecture. So yeah, so we have the model in place. I'm just kind of instantiating and kind of compiling and training the model over here. 20% of the data is used for validation. So this is without quantization aware training, without applying any quantization effects. So let's see. So we have like total parameters around like 4 lakhs, and total size is coming around 1.53 MB. So later we'll look into the quantized model size. Yeah, so calculating the accuracy, it's around 47% with 10 epochs with a very simple model. So it's image data and we are using DenseNet, so it's not like that accurate. We're not using CNNs. So now comes the quantization aware training. So we already have the model previously defined, few dense layers. We're applying the TensorFlow optimization library for the Keras model. So this is the quantized model. Then the similar process as we did above, compiling the model, getting a summary, and then kind of doing the training for 10 epochs. So we saw that, I mean, quantization is a lossy, right? But here we'll see that even if we apply quantization during the training process, the model accuracy is not affected. So it's almost the same as what we saw with without quantization during the training process. So we'll see that. And yeah, so here you can see for every layer, quantization layer is like kind of wrapped because we are applying the quantization Keras using the TensorFlow optimization model compared to the previous one where there were like no quantization wrappers around it. So let's see. Yeah, you might say that the model size is coming out to be similar to what was present before. Yeah, so one thing to note is like quantization of a model is not like finally it's not a quantized model. Only during the training process those effects are applied, but the final model is not quantized. So creating a quantized model is a separate step, right? So it's like two different steps. One is at the training, quantization effects are applied, and then you have a final model which is not reduced in size or so. So you'll have to apply like separate quantization techniques post the training to kind of reduce the model size. So we'll be going through the TF Lite, TensorFlow Lite version to kind of uh, go from trained model, which is quantization, which has gone through the quantization aware training, and then kind of going from full precision to intent precision. So we'll be comparing that. So the training is complete here. So it's 46.7, and if you look here, it's like 47. We haven't seen much of accuracy loss, even if we apply the quantization during the training. Yeah. So now quantization after training, right? So now is the point where the model size is getting reduced and the inference is like getting faster. So let's do that with the help of DF Lite converter, where you're passing the quantized model, which we already trained. And so by default, it's like kind of converting the full precision to like int 8. Yeah, so now you can see the quantized model is 0.38. And so if you convert the same, not the same model, if you convert the float model to TF Lite without applying any quantization effects, so you can see like it is still the same as the original one, so 1.53. So this is without the quantization, just the float model, right? And this is with the quantization, so you can see the difference in the model size, and similarly we can compare the model accuracy as well. So yeah, so I've taken the references from the official TensorFlow blogs, so you can have like go through the details, the more details over there. So let me know if anyone has any questions. I'm not able to hear.
Oh, I'm sorry. I was on mute.
Yeah.
I do not see any questions. So anybody have questions, please type in the box. In the meantime, I have a question to ask you. Is that if we have different backend, now that Keras supports different backend, is the quantization process still the same? Or it's different depending on the backend?
Yeah, to be honest, I haven't tried with different backends. I've just used the default one for now. But yeah, I think definitely we can give it a try. Or if anyone else has tried.
Yeah, I'm wondering
Yeah.
like if Aritra or Aakash
Yeah.
tried, since they work on the. But is there any other questions? If not, thank you very much, Rajesh, for your great talk. The quantization on device has always been like my area of interest. So talk is great. So
Thank you. Thank you so much.
Yeah, with that, thank you. And then I'll talk to you later, Rajesh.
Yeah.
And we're going to have the very last talk by Anshuman. And hello.
Hi.
Hi.
Hi, Margaret.
Hi. I'm not able.
Yeah.
Oh, I see your camera,
Hi.
your video now. And hello, welcome, Anshuman. And thank you for your patience for waiting till the last one to speak. Tonight we have so many speakers, like 6 speakers. This is a great night.
Yeah.
And
Indeed.
yeah. Yep. And I also want to thank everybody for sticking with us till the last talk. And if you could share with me your screen, I will add it to the live stream.
Just let me show it.
You just click on the present button to share your screen. So this last talk that Anshuman is giving is modular NLP workflows with Keras NLP, right? So,
yeah, so I think the screen is up.
yep, we can see it now.
Yeah.
Thank you.
Thanks, Margaret. I think so. I can start. So thanks, Margaret, for having me today. I am Anshuman, and I am currently working at Flip as an ML engineer. It's a US-based startup still in stealth, and will be going out public soon. And I have recently completed Google Summer of Code at TensorFlow, and I was working with Keras team, building KerasNLP. And in my free time, I love to Kaggle and notebooks and with dataset master. And I have just graduated from NIT Warangal. And if you love about anime and manga, so you can hit me up. My Twitter DMs are always open, so that's the best way to reach me out. So regarding this talk, I have a chat box here, right? So I think through that uh, I'll try to get the question. So let's, even though it's hard to make a hybrid talk interactive, let's try to. So if maybe Margaret can share the questions that audience is having. So uh, please feel free
Yeah,
to
I
take
will
over the
do.
chat.
If there are any questions, I will share them. In the meantime, I feel like your audio is a little bit low. Is there any way we could increase the volume a bit?
Just give me a sec.
If possible.
Yeah.
Thank you.
How about now?
Just go ahead and keep talking. If I cannot
Yeah.
hear
Good.
it, I'll let you know.
Yeah, sure. So here is the agenda for today. So we are gonna be first of all diving into know the quick intro that what NLP is, then what large language models are, then how they are trained, and we'll see what's Keras NLP, and we'll try some demo, and we'll see how it presents a new way of designing models through for large language models, right? So NLP is like natural language processing. It is like I would say when your input is text and output is text, and you want computer to understand your natural language instead of your code, right? So let's say the example of ChatGPT system that you tell ChatGPT to do everything in natural language, and it replies in the same. So that's how it is in a very no user friendly way. So natural language processing has lots of tasks. Like if you are a geek, you'd have heard about text classification. That's one of the most basic ones. Obviously chatbots, and then you have question answering. Chatbot uses that task, and semantic similarity. Okay, hey, I have sentence one and I have sentence two. Are they both semantically similar? Emotion detection, etc. Right? And text generation and summarization, etc. So there are lots of tasks about in the NLP domain, right? So just give me yeah. So let's see what large language models are. So I hope you have learned about know about like basic neural networks. So large language models are transformer, but it's a very big transformer. So in terms of parameter, like they have billions of parameters, right? So Chat GPT uses a GPT model under the hood, and it's a large language model, right? So yeah, so large language models are, again, as the word suggests, large language models. And language models are the neural networks of machine learning models that take text as input and text as output. Obviously, a machine algorithm, I would say, machine understands only numbers. So it is an intermediate process of tokenization of strings into numbers and all, right? I'll let me try to, yeah. So yeah, so on the left in the screen, you can say a image of transformer that was released in 2018. Attention is all you need paper. So from there, this field boomed, and we have here today where we have ChatGPT, GPT-4 like models that are actually into the mainstream. So like some of the examples of how evolution of transformer went from Elmo to Bert that was released by Google to Llama and Palm and GPT-4 that we have now. So over the time, the size has been increasing. As you can see, the Bert was of around 340 million model, and Palm that is released by Google has number of parameters in the range of 540 billion. So that's this much large the models become. The more the parameters, the better the model can learn and understand the uh, corpus. So LLMs are trained in this fashion generally, although there are others, but this is very popular. So we take a large corpus and we train the model, pre-train the model on it. Uh, it it makes model learn, get the domain knowledge, not the domain knowledge. It gets the gets model the general knowledge, and it understands. Okay, this is kind of language I'll be dealing with. So let's say you want to train. Let's say you want to train a model on semantic similarity. So you will take a BERT and you will train on general language words. That is done by mass language modeling. And when the knowledge BERT model actually knows what language I'm dealing with, and what vocabulary is, etc., all general knowledge about the language, you can fine tune it on the downstream task, let's say semantic similarity or text classification, whatever it is, based on the language, right? So then we make the models knowledge very specific to the domain, the task that we have at hand. So okay, now we'll dive into KerasNLP. So KerasNLP is an extension over the core Keras API, and but it has all the features that you need for building your language models and large language models as well. So this was a tweet that Transfer did when it was released. So the API of the Keras NLP looks like this. We have models, we have tokenizers, we have layers, we have metrics, and we have pre-processing layers. So you can get started by just doing a pip install KerasNLP, and by the way, KerasNLP supports multi-backend, so you can use JAX and TensorFlow or PyTorch, whatever you want, right? So you just need this one statement. So we can. So I'll share a collab at the end of the talk. I think my audio is pretty much not clear, so it makes sense to show the example. So uh, one could so to get started, if we can download the SNLI dataset using this command showed on the screen, and you can just initialize your dataset data loader using the Keras utils text dataset from directory, and specify the batch size and the dataset. And then yeah, using this just one line KerasNLP.model, you can create a model from pre-trained pre-trained model, right? So dot from preset is similar to what you use from pre-trained in Hugging Face. So this will instantiate a BERT classifier model, which will be a BERT backbone, then a classifier head attached on it, and you can just get some prediction by just calling classifier.predict. That's it. You don't need to do any hard stuff. So that was pretty quick example. I'll share the collab after the talk. So let's as the topic of the talk was like modular design with KerasNLP, right? So let's see what KerasNLP has in store for you. So like I mentioned earlier, KerasNLP's API is divided into these 5 parts. Like we have metrics, models, layers, tokenizers, and samplers. Right. So samplers are more on the generative side for, let's say, uh, uh, what method you want to use for generating tokens. Will it be greedy or will it be any other methods like beam sampler, etc. method, right? So So just a quick intro. So tokenizers are the piece of block that convert your string natural language into tokens that a model can understand. Metrics are used to evaluate your model, how is it performing. Layers are actually the building blocks for the models, and models are your, we have backbones. So let's say we have Bhat, Roberta, etc. Right? So we have backbone, and based on the task specific use case, you could have generative pipeline, or you could have classifier pipeline. So models have all that stuff in place, right? So the Hugging Face actually library is built to make the job easy, make the life easy, but it does not provide you, that much freedom to customize your model. So here is a tweet that actually tells that blah blah blah. Okay, this is the case, and you cannot customize that. So I'll tell a personal use case. So I was working on uh, uh, a production-based model where we needed constraint decoding in the generator, right, for T5 or whatever model was, right. So uh, I could, to do the implementation of constraint decoding, I would have to copy the entire files of Ring Face and just change the one line. KerasNLP saves the day for you by providing you modular architecture. So I can, let me know if my other tab is visible. Is it? Yeah. So cool. So we'll see how it is and save the day for you. So here is the repository of KerasNLP. So earlier we discussed about samplers and uh, tokenizers, right? So we'll see first about the samplers, right? So the Keras NLP has all these APIs for going to samplers. And then let's say we take the greedy sampler, for example. The token that has highest probability, that will be selected. So that's what greedy sampler does. So in my use case of constraint decoding, I wanted to implement a custom logic in getting the next token. Let's say I have let's say if a token was generated, then I want to inject a logic that if this token was generated, you have to follow this path and do this, and then get back and continue generation, right? So these kind of things can be done easily by subclassing this greedy sampler. Let's say class custom greedy sampler of greedy sampler, and then implement your own get next token method. By this way, you can, without much change, much hassle, you can easily customize your sampling method, and then use that this sampler to into the your model that your GPT you are using, and then by that you can get that implemented, right? So your job is easy. You don't have to do much change in the earlier two lines of code that I showed you regarding creating classifier and doing the predictions, right? So so let's say if you want to create a custom task, let's say, so generally we have, let's say, so in the models in the Keras API. So we have these many models available. So there is this class task.py. So the general number of I showed you earlier the number of tasks, right? So semantic similarity and text classification, text generation. So for now, the tech library does not implement a semantic similarity task. So if you want to implement one, so you could just subclass this task model and uh, uh, like uh, you can, let's say we have from preset method and this summary method, right? So you can only implement like corresponding loss mismatch functions and initializers what you want. Like you can have an extra head over the top of the backbone, and then you could implement the forward pass for that by not writing entire transformer code from scratch. So you can implement your custom tasks as well using the Keras NLP task. So I think I presented the wrong screen, so sorry. So yeah, here, yeah, so here I was talking. So in the task, you can subclass this uh, class and implement your custom methods for your task. So let's say for semantic similarity task, you'll have two sentences. So you can pack them together using sentence packer, and you can implement that in here. And then you could specify your custom backbone. You can specify your custom preprocessor. You can also specify your custom extra neural network heads that you can have in your task, right? So and then we have generative task as well, like I already talked about uh, the samplers, right? So for generative task, we have this causal LM class. So as you can see, this generative task does the task for generation, and it's similar. It subclasses the task and implements all the beam sampler logic under the hood. If you want a custom generative task, you could just subclass it and implement your logic, initialize your blocks, and that's you are done. Also, if you want to implement a custom caching, you can do with more subclassing this, overriding this call with cache method, and that's it. You can also modify your generate step. So the point is behind all this talk that uh, is my screen visible?
You're not sharing your screen anymore.
Yeah. So the point with all this talk that you can subclass all do-do-dos, right? So Hugging Face is an excellent library for those who want to do the job quick, build modern production. But if you are the one who wants to do who does not want to implement from scratch, but you still want the same flexibility, KerasNLP is for you. You can implement custom generators, custom backbones, etc. by doing much less job. Also, we have designed in such a way that you don't have to worry much about the specific once you change a custom block, right? So that's how it is. So you can scan this URL, and this will bring you to, let me present this tab. So this will bring you to a guide that I authored with Matt. So which explains about how can you implement your custom backbones, custom models from scratch. So keeping the time of the event in mind, I can share. You can just go on this and click on the collab, and it will open the collab for you, and you can run this example for yourself. Right. So earlier, this guide was only used to use only one backend TensorFlow. Now it uses all the PyTorch and JAX backend. So to change the backend, you can just set the environment variable that hey, this use this backend. Uh, let me let it load first.
So far, we don't have any questions. So, are you trying to load something? I see the screen says loading.
Yeah, the collab is loading.
Oh, you're trying to load the collab, the one that you were showing on Keras.
Anyways, I think so.
Yeah,
this is a pretty detailed guide. So I think I'll share this in the chat soon, and you can just go through it, and it will tell you how can you create your custom models and custom tokenizers, etc. Right. So and also a detailed guide on pre-training your models from scratch without doing much hassle. You can mass language modeling, all those tasks that are generally involved in pre-training and fine-tuning the models. All there, everything is there in this guide. So feel free to check it out. Awesome. So do we have any questions?
I have asked, but no one is asking a question yet. I am gonna just put the link in here, and which is the one pre-training a transformer from scratch with KerasNLP. And I think great talk. Thank you. I think he also made a great point about, Hugging Face versus Keras, when to use which one, right? If you want to use NLP. And John said thanks for the presentation and everyone, and thanks, Margaret. Well, thank you, John. And let's see. I think Aaron says, this is the second demo today that has suggested using inheritance to customize Keras classes. Is that a typical pattern across Keras? So that's a question.
Yeah. So Keras actually is designed on the principle of progressive disclosure of complexity. So if you are a newbie or you are a student, you don't have much knowledge about details of uh, uh, what math underlies between the models, you can keep it very simple. Create the model, call model.fit. But if you are a researcher, you can customize all your steps, which everything that's there in Keras, it's customizable. For example, all the stuff that I told you on the KerasNLP side. And if you want to, even if you want to customize your forward pass, you can do that. So Keras has all the tools for you. It's just that if you want to use it, you can customize it and make it according to you. Just a side note, so yeah, the KerasNLP, KerasCV, and Keras Core, which is Keras 3 now, are welcoming contributions. So if you want to contribute, so you can just go to Issues tab and see those that are open, and just comment, hey, I want to contribute. Then that's how you can get started with KerasNLP. So this is a QR. I hope it still works. It's an old one. So you can scan me on or connect me with this username on Twitter. Anshu is me, and I prefer Twitter DMs over LinkedIn. Right, so that's the best way to reach me out. Thank you for the talk.
Great, thank you so much. I'm gonna add all the speakers who are still here, so don't leave. I think a couple the speakers are still around. Let me make sure I add everyone. I think most of us are still around. Maybe we're missing one person. So, Anshuman, thank you for the talk, and thank you so much for waiting until to be the last speaker. And I also want to thank everybody who's sticking around to, still watching it on YouTube as well as our webinar. And Aakash, Aritra, could you share your screen if possible? And Suvaditya.
Yeah, sure.
I think we're just missing Usha. So I just want to say goodbye to everyone. See your faces and Aakash. So yeah, thank you so much. Like my fellow ML GDEs and also Anshuman, Google Summer of Code participant. And I really, really appreciate you get up so early to speak for our event. Great talks. And I will make sure like people who could not join our live stream and the webinar today, and be sure to watch your talks.
Sure. Thank you, Margaret, for.
Thank you so much.
This was fun.
Thank you. And
Thank you.
thanks everyone. I'm going to click on end stream now. Goodbye everybody who's on YouTube and the webinar. Thank you very much. And one more thing, I want to thank Clive and our GDG organizer. He's not in here, but he's been watching from YouTube channel and also webinar, and we were chatting back and forth to make sure the audio and video quality is good. Thank you, Clive. And thanks everybody. I'm gonna end the stream now. Goodbye.
Thank you, everyone. Bye-bye.